There is a smell living inside 94 million homes right now. It's not just a scent, it's a biological structure buried deep inside carpet fibers, mattress foam, and sofa padding. Most homeowners think they've cleaned it, but their lungs know the truth. The professional cleaning industry often overlooks a critical scientific fact. You cannot wash away a crystal. They sell you steam cleaning and surface detergents, methods that look great for 48 hours but eventually fail. They aren't necessarily lying to you, but they are selling you a temporary fix for a permanent molecular problem. But for less than $5, you can use bio-enzymatic science to perform a total extraction that the professionals rarely mention for home use. Today, we're stopping the reactivation cycle for good. Welcome to the science of what's really under your feet. Why has this miracle biology been scrubbed from the average homeowner's vocabulary? It wasn't a secret conspiracy. It was a masterclass in profit-driven perception management. The year was 1953. A team of microbiologists at a municipal wastewater plant in Ohio made an observation that would quietly redefine sanitation science. They isolated specific strains of bacillus bacteria that didn't just filter waste. They produced a high-affinity enzyme called uricase. This wasn't just another cleaner. It was a biocatalyst. The industry already knew that uric acid was a molecular fortress. It survives boiling water. It resists bleach at full concentration. It even survives the industrial solvents used to dissolve petroleum residue. But these microscopic organisms consumed it as food, dismantling the crystalline structure, molecule by molecule, until only carbon dioxide and water remained. By the 1960s, this technology was the gold standard. The U.S. military deployed concentrated enzyme formulations to decontaminate field latrines in the jungles of Southeast Asia. Hospitals used it for surgical textiles that traditional autoclaving couldn't fully sanitize. The science was proven, published, and documented in every sanitation engineering journal in the country. But as the suburban carpet boom of the 1970s and 80s took off, the residential cleaning industry made a calculated decision. They realized it was far more profitable to sell you an aesthetic illusion than a structural reset. They chose to build a $7 billion empire around high-heat steam and synthetic fragrances. Methods that make your carpet look clean for a few days while leaving the uric acid fortress intact. They traded a one-time $5 biological solution for a $300 recurring service loop. Today, we are stripping away that marketing veneer and reclaiming that military-grade biology for your home. Standard household cleaners fail because they are fighting an enemy that has already changed its physical state. When you spray your carpet with store-bought pet odor removers or blue dish soap, you are treating a deep tissue contamination like it's a surface spill. It's not. When a pet or child has an accident, the warm, acidic liquid doesn't stay on the surface. Driven by gravity and capillary action, it saturates the carpet pile, bypasses the woven backing, and fills the foam padding beneath like a sponge. As the liquid evaporates, the water-soluble components, urea and creatinine, are easy to lift, but they leave behind the final boss, uric acid crystals. The uric acid fortress. These aren't just stains, they are microscopic, chemically resistant glass shards that have undergone molecular fusion with your synthetic fibers and porous subfloors. They are not soluble in water at any temperature. They resist every conventional detergent on the market. Cleaning industry research has documented these crystals remaining chemically active in carpet padding for up to 20 years. The reactivation trap, the industry's secret revenue stream. This is where the cycle becomes insidious. When you pay for a professional steam cleaning, the hot water removes the surface urea. The smell disappears for 72 hours, the honeymoon phase. But the steam never touched the crystals buried in the padding. The moment the humidity rises or a child crawls over the spot with damp knees, you trigger the reactivation cycle. The moisture rehydrates the dormant crystals, causing them to release volatile ammonia gas once again. The industry counts on this cycle. Every time the smell roars back, it's another service call and another $300 invoice. The biological strike, entering the predator phase. To destroy a crystal, you don't use soap, you use biology. Enzymatic cleaners are not cleaners in the traditional sense. They are biological specialized units. They contain dormant bacillus spores that undergo kinetic activation the moment they contact the uric acid. Through a process of alkaline hydrolysis, the uricase enzymes act as a chemical wedge, specifically engineered to snap the molecular bonds of uric acid. Simultaneously, protease and lipase dismantle the surrounding proteins and organic fats that act as a shield for the crystals. This is a violent, one-way digestion process. They transmute rock-hard crystals into harmless carbon dioxide and nitrogen gas, both of which simply evaporate. Once the food source is gone, the bacteria die off, leaving your carpet truly sterile at the molecular level. You aren't cleaning the fabric, you are performing a total biological extraction. Stop thinking like a homeowner with a spray bottle and start thinking like a biochemical engineer. You aren't just cleaning a stain, you are engineering a living reaction inside your floor. If you skip a single step, the biology fails and the crystals stay. Here is the professional protocol. First, the color fastness audit. Do not skip this. Every carpet and sofa fabric is dyed differently, and professional-grade enzymes operate at a specific alkalinity to trigger the reaction. Apply your solution to a hidden corner, wait 15 minutes, and blot with a white cloth. If any color transfers, your fabric uses unstable dyes, and you risk a permanent chemical bleed. Protect the aesthetic before you save the substrate. Second, target acquisition. Use a 365-nanometer UV flashlight. Human eyes are useless here. You must use the specific spectral frequency to reveal deep-seated crystals that lower-quality lights will miss. Black out the room and find the yellow-green fluorescence. This is about precision targeting. The deposit zone buried in the padding is often 3 times larger than the visible stain on the surface. Third, kinetic activation. When buying your solution, look for a bio-enzymatic formula that explicitly lists active uricase and protease. Dissolve the powder into warm water at exactly 100 degrees Fahrenheit. Heat is your kinetic catalyst. If the water is too cold, the bacteria remain in a state of microbial stasis. If it's above 120 degrees, you thermally denature the enzymes, killing your strike team before they even touch the floor. Fourth, hydraulic saturation. Urine is a liquid driven by gravity and capillary action. If it reached the subfloor, your solution must too. You must pour, not spray. Apply the liquid until the carpet, the padding, and the wood beneath are fully saturated. This is hydraulic displacement. If the enzyme doesn't make physical contact with every microscopic crystal, the chemical bond remains unbroken. Fifth, the biodome. This is the step the industry skips because it kills their profit margins. Cover the area with plastic sheeting or a heavy-duty garbage bag for 12 to 24 hours. Bacteria require 2 things to survive: a food source and moisture. The moment your carpet dries, the bioreaction stops. By sealing the area, you create an incubation chamber, giving biology the time that chemistry never had to finish the digestion process. Finally, the molecular reset. Remove the plastic and let it air dry naturally. Do not use high heat. As the moisture leaves, it carries the byproducts of the reaction, nitrogen and CO2, out of the fibers. For old or multi-layer deposits, repeat the protocol once more. Once the food source is gone, the bacteria die off, leaving the material truly sterile at the molecular level. The reactivation cycle is officially broken. The cleaning industry survives on the steam fail repeat cycle. They need you to believe that a persistent smell means you need a new carpet or a more expensive service. But science shows us a different path. When you spend $5 on the right biology instead of $500 on the wrong chemistry, you aren't just saving money. You are liberating yourself from a predatory consumer cycle. The original fibers are still good, the structure is still sound. All you needed was the right molecular key. If this insight saved your home and your nose today, share it with someone struggling with the same invisible problem. I'll see you next time on What They Hide.